Welcome, everyone. This is Jim Sporer with ISSIP, the International Society of Service Innovation Professionals. Today, in our book series with Business Expert Press, we're lucky to have Hugh Taylor to tell us. We're going to learn a lot today about the edge data center and the future of connectivity. But before we do that, I just want to share with you that ISSIP does have a book series with Business Expert Press, and we do encourage our members, ISSIP members, especially those who've never written a book and have expertise in a particular area, to consider submitting a book proposal, and we do provide some support for helping people get their first book done. So with that, I'll ask Hugh, who's with us here today, to go ahead and share his screen or introduce himself.
Yes.
However you would like.
Yes.
You.
Yes. Hold on one second. Sorry, hold on a second. Can you see that title slide there?
We can. Yeah.
Okay, great. I have to apologize. There's a little bit of background noise in and out. There's a bulldozer going past my house back and forth, which they timed it very well for this online presentation. But so hopefully you can hear me okay. But anyway, thank you for having me, Jim. I really appreciate the opportunity. So today we're going to talk about understanding edge data centers and their role in the 5G and IoT revolutions. And the pretext for this, as Jim mentioned, is that I have a book out now with Business Expert Press called The Edge Data Center.
And
what we're, yes.
Go into full screen mode, it might look just a little better.
Oh, okay, sure. Let me work on that. Hold on a second. Okay, is that better?
That is.
Okay.
The speaker notes, though.
Yeah, I'm sorry. I don't know. Now I'm getting all kinds of free tips from
left it the way it was.
Yeah.
It was the way it was. I was just trying to optimize.
Okay. Maybe I will send it back to what it was, because it's just, oh, here we go. I used to work at Microsoft, so I'm very pleased that they're offering me all these like freebies on top of it in the middle of the presentation. But just so today, over the next 20 minutes or so, we're going to talk about trends in telecom and the technology sector that are pushing what I and a lot of other people believe will be an explosion in edge points of presence, and we'll talk more about what that means and the importance of it. And in my view, and in the view of others, that the edge data center will be critical to realizing this vision of edge computing, and I'll talk about what that means. And we're going to talk about the edge data center, what it is, and why it may be hard to deploy, and what can be done about those challenges. So that's the focus for the presentation today. Just briefly, a little bit about me. I've been working in the enterprise tech and cybersecurity fields for about 22 years now, mostly in marketing and product management roles. I have a Paleozoic Harvard MBA, and I've been writing content for some of the major telecom tech players, and that's actually how I found myself getting involved in edge computing, because as I was working with these are some of the major network equipment providers and software providers to telecom, and I saw that they were grappling with issues like, how are we going to support 200,000 edge points of presence each with multiple servers in it to support 5G applications and so forth. And I kept thinking, what, this is sort of a real estate problem. Like, where are all these edge points of presence going to go? Who's going to build them? Where are they going to go? So it got me into a thought process. I ended up starting a business called Edge Site Partners, which is involved in edge data center development. And I also wrote this book called The Edge Data Center to explore the issue more deeply. Now, to get into this now, I may be covering material that you already know. So forgive me if you already know this, but I think sometimes it's very useful to get some basic definitions out of the way at the top. So what is the edge? So the edge in enterprise technology and networking refers to the relationship between an end user's device and the core, which a core would be like hyperscale data centers, like the big ones in Virginia, or corporate data centers. And the edge, just using this little diagram here, the edge is out here. And the edge, they're at the edge of the network, really. The network defines the edge. In this case, the public internet is the edge of the network that connects you to the corporate network or to the internet core hyperscale data centers. And so what's happening, and this point of connection might be a 5G cell phone tower, or some other kind of multi-edge access computing or MEC facility, and some sort of edge data center. And we'll dive a lot more deeply into this in the next couple of minutes. Now, the main point of the edge is to bring computing and data and storage closer to end user, physically closer, okay? And why? So why do you need this? The basic reason is lower latency. And this, as we have now billions and projected to billions and billions of more devices, ranging from smartphones to PCs and all kinds of industrial sensors and other devices that need ultra fast connectivity to networks. And for examples include connected vehicles, drones, and I'll go down a bunch of use cases. End users either want or absolutely require low latency response from computing and data sources. So this requires moving those computing and data resources closer to them physically to bring down the latency, because even though the internet is fast and networks are fast, the round trip for a request for computing or data to the core might be 20 milliseconds, which most of us wouldn't even notice. But if you're in a connected vehicle, that's a long time. There's also a concept of data gravity, which involves data that's generated at a site, like a manufacturing facility, where for many reasons, it's better just to keep that data where it is instead of pushing it up into the cloud. And so that's creating a need for edge data centers to be deployed in industrial facilities and so forth. And there's also redundancy. There's a lot of interest in creating redundant sites on a localized basis. For example, a company might want to have a small redundant backup facility in the city of Los Angeles, even if their main infrastructure is in Arizona or something like that. So they end up deploying an edge data center. So those are some of the drivers of this. And just one more way to look at it is if you're in a connected vehicle, if you can see this, I'll just zoom in on this a little bit, that if you're in a connected vehicle, if you're connecting to a data center, cloud data center through a cell phone tower, there's latency in this back and forth request for data or computing, which may be too slow for the vehicle, might not even be safe. And so by putting a micro edge data center at the RAN, the radio access network tower, you've shortened that distance and latency quite a lot. Now, just so you know, it's not that simple, as everything in tech is never quite that simple, but that's the basic idea. Now, what does an edge data center look like? So I want to these are some pictures, and I'll explain what they are. There's a little bit of a disagreement, you might say, or difference of point of view on what an edge data center is. Because for one thing, edge computing is not new. Like there's always like this weird dynamic when you say, hey, I'm doing edge computing, it's the new thing. And people are like, no, it's not. It's been around for 25 years. What are you talking about? So there is the old edge, you might say, which is, for example, somebody deploys a 100,000 square foot, 50 megawatt data center, in the suburbs of Chicago, and that's considered the edge because it's not the core. It's not a 1 million square foot, gigawatt data center in Ashburn, Virginia. That's the core. It's, as far as this person is concerned, a relatively large data center in Chicago is the edge. And that is true. And this is, if you look at the partnership between, for example, Verizon and Amazon Web Services, for what they call their, I'm blanking on the name of it, wavelength zones. This is what they've done. They've they've partnered with Verizon to deploy Amazon Web Services data centers closer to about 19 metro areas in the US. And that is definitely edge computing. But what's newer is what people are calling the micro edge. And that's what this is. And this is an example. So on the upper left, we have, this is from a company called Edge Presence. This is a 140 kilowatt edge data center. It's about the size of 2 shipping containers welded together. This is a side view. It has about 15 server racks, and it's a self-contained unit. It doesn't have a person. There's a person can go into it and fix things or whatever, but it doesn't have any staff on site. And this is actually a relatively large edge data center. There's also, if you look at the right, this is a about a 10-foot square, I think 100 kilowatt edge data center from a company called Rackworks. It really looks like a little pod like that. That's what, here's one other one on the lower right. These are popular because they're prefabricated. They can be brought in like on a truck and bolted onto a concrete slab and pretty much have an instantaneous data center. And then there's also cabinets. A lot of edge data centers are really basically equipment cabinets. They have some extra things added to them. And you get it also into this funny sort of dialogue, like for a data center professional, like this is not a data center, you know, like a steel box on a telephone pole to them is not a data center. It's like an insult to their professionalism to even suggest such a thing. But in terms of computing and the logical relationship between the client device and the compute instance, it is a data center. And that is something to keep in mind. So that's what the edge data center is. Now, why do you need these? So the data center, edge data center, in my view, is critical to realizing edge computing. And it's kind of a funny thing. It's for some people, they don't really think about it. It's an underappreciated element of the edge computing, you know, revolution. People may forget or not acknowledge that the edge is about a physical location. And I've had this conversation a bunch of times where there's a difference, if you look at my first bullet point, between the edge versus the edge, which people, I think in their minds, it's kind of like the cloud. It's like this abstract place in the computing landscape called the edge. And like the cloud, they don't really think about where it is, but it's the opposite of the cloud. The cloud is location agnostic. It literally doesn't matter where the compute is, and you don't even know, and you're not supposed to know. The edge is completely different. It has to be in a certain location, and you have to know exactly where it is. So there's a practical element, and to do that, you need an edge data center of some kind. So the question then is, where will it all go? And that's a challenge that the industry is confronting. Here are some use cases. I won't. This is a bit of an eye chart, I'm sorry, but just I'll go down some of the use cases that are happening or expected to happen for edge data centers. One is games, apps, and entertainment, which may seem trivial, but it's a big industry and people really, really want fast access to their interactions. So it's a driver of edge computing. There are edge computing as a business itself. So some of the data center REITs like Equinix or colocation firms like Rackspace are starting to offer edge computing as a service, and they are building and deploying these kind of edge data centers. There's telecom, like 5G tower companies like American Tower and Crown Castle are deploying edge data centers to tower sites. There's metaverse, which maybe it's not really happening the way people thought, but it is a factor. There are internet services like maps and autofill and stuff like that, where the edge is needed for that sort of ultra fast response from a compute. Like people may not realize, if you're using a smartphone and there's autocomplete in your texting, that may be coming from a compute instance, not from your phone. So that autofill, which appears instant, is actually the result of a data request back and forth to a compute instance. And so the faster that can happen, the better it is. There's enterprise computing needs for the edge. There's transportation, which some people think will be a major driver of this, like connected vehicles. Notice I'm not saying autonomous vehicles. I think that may be coming, but there's a lot of vehicle connectivity that's happening now. And in the next couple of years, it isn't necessarily autonomous vehicles. There's industrial IoT, like robotics. A lot of robotics use cases need compute that's extremely low latency because robots can only carry so much data and compute on them. So they need to work with a computer that's nearby. Financial services like high frequency trading, smart cities may need edge. And then call centers, it's kind of an interesting use case where bringing in an edge data center with a connectivity also provides like a lot of rich telephonic connectivity. So call centers may want to use them too. So those are some of the use cases. Now, the question is this really happening and how big is it going to get? Now, this, again, I'm sorry, it's a bit of an eye chart. I'll just give you some of the highlights. Different entities have different estimates of what's coming. One estimate is that the edge data center industry was about $9 billion last year, growing at 17%. The US market, here's a different estimate, 4.3 billion, Chinese market, 1.6 billion, Japan and Canada growing 14.9%, 14.7%. So it is not a big part of the data center business, but it is definitely growing. And there are some very, very ambitious estimates of what's coming as use cases like connected vehicles come online that'll be much bigger. I'll just share one or two of these. Are some quotes from big thought leaders like Mark Zuckerberg said, creating a true sense of presence in virtual worlds delivered to smart glasses and VR headsets will require massive advances in connectivity. And what he's talking about is the edge. Sean Shahini, who's an entrepreneur in Edge, also said that this is the biggest infrastructure project after the interstate highway system. Instead of building 100 antennas to cover Manhattan, we now have to build 5,000 to 20,000 antennas. So the edge goes hand in hand with 5G and smaller bandwidths and newer types of micro cells and so forth. So so the question is, where is this headed? And so this is a little thing I like to show, what's coming. And I shared this picture, and I like to say, does anybody recognize this little scenic spot with the farmhouse and two roads coming together to a point painted in 1861? And the answer is, it's Columbus Circle in New York City. That's what Columbus Circle looks like now, and that's what it looked like in 1861. And I believe that as this infrastructure gets built, it will seem inevitable that this is all going to get built out, because device density and device proliferation is not slowing down. The need for fast connectivity is not shrinking, it's growing. And so there will be, however it comes into existence, my view is that it's going to happen. And there's going to be this infrastructure. And once it's built, everybody will be like, of course, it's like Columbus Circle, like, duh, of course it was coming. But if you were looking at it in 1861, you might not have thought, well, one day there'll be like 1 million people living here, maybe not. So that said, it's not so easy, right? You have to find space for what could be thousands or even tens of thousands of distributed sites, and it's going into premium real estate, which is different. The data center construction model has always been find really cheap land outside of the city and build a big data center. This is totally the opposite. It's find the most expensive real estate in the most densely populated areas and build something small. And there's not so minor issues like getting the electric power you need and bandwidth connectivity. There's a lot of technological issues involved, and there's a lot of business transactional issues you need, which become more complicated. As you might be dealing with hundreds or even thousands of partners. And as an example, if you're building out infrastructure for connected vehicles, you could be deploying edge data centers to tower sites owned by hundreds of different tower operators. So you have to have a legal agreement, service contracts, and all kinds of things with multiple entities. So it's a complicated story. And so what I suggested this is like my thing, in my business that I talk about in the book, is you have to have some sort of platform to manage these multiple data centers, which deal with things like the site selection, dealing with property owners, dealing with all the technologies that you're deploying, servicing them, and so forth. And I called it location-centric multi-edge management operations, or MEMO platform. This is what I'm proposing the industry needs, as well as standards for dealing with all the transactions and integrations that occur. But those are some thoughts on the edge data center and what I think is coming, and the role that these data centers will play in 5G. And I wanted to share that with you today. And I just appreciate you taking the time. And I will now open the floor if anybody has any questions.
Yeah, thank you, Hugh. Great, great concise overview. And I thought your book was great as well. I found it really concise, clear. And I guess my question is, since we're in a time of accelerating change, and I'm sure, a lot of AI applications will be on the edge, probably
Right.
data local to the learning and things like that. I'm just thinking, do you have some thoughts on, well, two aspects. One is there's a maintenance cost to this, because in times of technological change, probably devices are shrinking, you'll have to upgrade.
Right.
Energy systems are changing. How is there an economic model, a spreadsheet that goes along with this? Is that part of your platform there, the memo platform?
Well, so for sure, the economics of edge computing are different from traditional core hyperscale data center operation. It's different. It's running 5,000 edge data centers versus one enormous core data center is different. But what's happening in parallel is there's a lot of investment now into making the process of managing edge data centers more efficient. You simply cannot manage edge sites the way you manage a core data center. You can't have service technicians rolling out on trucks to 5,000 different locations. There has to be a lot more remote automated maintenance. And what's also really interesting is the development of like completely user-proof technologies, things that just ship, get plugged in, and work. There's no setup, there's no fiddling around with stuff, because the assumption is either the person who's receiving it doesn't have the knowledge to do it, or doesn't have the time, or you don't want to pay someone to do it. So there's a lot of stuff coming to make these things a lot more manageable. But it is still going to cost more. And so this has to be worked into the model. So if you're renting, rack space at a co-location facility for $150 a kilowatt, all of a sudden at the edge, it's going to be $300 a kilowatt. And that's just reality. So, the market will have to adjust to this. But the one missing link here, though, and this is why people are often feel very entitled to tell me that I'm a complete idiot, is that the use case has not completely arrived yet. There is no big customer or killer app for the edge yet. And it's possible that it will never emerge. And it will become, as a friend of mine likes to joke, a $0 billion a year industry. So that is possible. There's also a really interesting alternative, which is being discussed, which is that as devices like the iPhone become more and more powerful, that they will be able to support each other as little edge compute instances, and you'll have device clusters that do all this edge computing for what my phone does it for your phone when I'm not busy, and your phone does it for my phone, and you won't need an edge data center. So that's another possibility. Or that connected vehicles will carry a lot more computing on board than is currently possible with cars. There's a lot of ideas out there. So those are some of the things that may be coming.
Yeah, that's really interesting. And I like how you're kind of keeping it loose that this is still evolving and it could go in many different directions, even the $0 billion industry.
Right.
In fact, that was one of the things I remember when I was looking at your book. I like it when people can be very skeptical about what they're advancing, and
Right.
that's humble and honest. I do think, though, that there will be a coevolution of this with, like you say, the increasing power of the edge devices themselves, but
Right.
so we know there's more robots on the way.
Right.
And
Yes. So this is an interesting area. I don't know a lot about it, but I've seen presentations from companies like Panasonic and Fujitsu on this, and they are grappling with this because if you have, for example, a humanoid robot, it can only carry so much computing and memory on board in its head, so to speak. It will need, you mentioned AI, it will need ultra low latency access to nearby computing that's very powerful for the AI models, the language model, all these things. And without it, these robots won't really work. So it's a bit futuristic, but this is what companies like Fujitsu and Panasonic are thinking through now. And so it's coming.
yeah, I think the construction industry is the industry that has the worst increasing productivity of all industries. You compare all industries, and construction, I think, is, by some measures, the lowest rate of increase of productivity. But certainly with robots coming, construction cost and maintenance will really be impacted by that. And I think that might play a big role in these edge scenarios as well. But yeah, thank you very much, Hugh.
Yes.
We've
Thanks for having
found
me.
that keeping these things to 30 minutes, more people from the community watch it, and we're
Right.
coming right up on that. But let me
Okay.
just check the chat to see if Zara had any questions. Doesn't look like it. Thank you very much again, Hugh.
Yes.
I
Thanks for
will
having me.
I'll post this recording to our ISSIP YouTube and the slides that you sent me to our ISSIP Slack, and do a little social media promotion of it. And thank you again. Have a great day,
Yes.
Hugh.
Yes.
And
Thank you. Talk to you later.
thank you.
Bye. Bye.